Welcome back to SPARC teaching. This is exercise 3 of the Malthy reconstruction. And so hopefully you've had a look at how to clean your mesh using Mr. P's Mesh Lab tutorials. So that one is quite comprehensive, and essentially what's in the exercise is a streamlined version of their instructions. So have a go with that. It is quite important to get the sort of duplicated vertices and everything out before this point, preferably. So this is the part after that where we start working with instant meshes. And so this is the first step to normal mapping our high resolution data set onto a low resolution version of our mesh. So first, what we need to do is to actually create that lower resolution version. So the reason we do this normal mapping is so that we can get all of the detail from the high resolution data set painted on to a more manageable data set, so a low resolution mesh, so that they can be incorporated into different experiences. There are lots of different ways to put your 3D models online, although they will often require a low resolution small file size to actually upload that for obvious reasons. And so this is why we're going to use decimate our data set, and we're going to use instant meshes because not only does this decimate things really well, but it also creates a quad mesh. In the exercise, there's a brief explanation on why we want quads, but essentially they're more regular than triangulated meshes, and a lot of Blender's functions require a quad mesh, or at least it works better with a quad mesh. And so this is how we work with instant meshes. So first you open your mesh. So we've got our cleaned mesh from the previous video, which I have put through the Mesh Lab cleaning process recommended by Mr. P. So it'll take a while to open it because it is quite a large file still. So the reason we're using instant meshes is because not only is it free, but it doesn't take up too much space on your hard drive when you install it. And it was recommended in one of the other videos I've referenced. Okay, and here's our mesh. So you can see how it's how Mesh Lab has filled in the holes in places. Mesh Lab's hole filling algorithm is a little bit more intuitive than others, but anyway, so what you'll want to do once your mesh is in instant meshes is that we'll want to ensure that align to boundaries is checkboxed, because you don't want your decimated mesh to be larger or to cover a larger area than your original mesh, because otherwise that causes issues when you are normal mapping. So you can check a couple of these other things, those are all fine. When you get to the target vertex count, you might want to consider do this a couple different times, because ideally you want a good amount of the geometry retained so that when you paint the detail from this original mesh onto the decimated mesh, you want it to have a bit of definition, otherwise it might look a bit weird. But at the same time, you want a small file size so that it depends on what sort of outputs you're looking at. If you want Sketchfab, you have to make sure the entire settlement data set stays under a certain file size limit, unless you pay money for a higher tiered account. But basically, knowing what you want to put this into at the end point, that's a bit more useful, knowing what file sizes you have to adhere to. So enough of that. So we have aligned boundaries aligned there. So we'll go for around 3000 vertices first, see what we get. So you hit solve here for orientation fields. That's fine. Then you'll hit solve again for position field. Now once that's finished, we'll go to export mesh, make sure it's pure quad, and increase that to 1 smoothing iteration, and extract mesh. And so this is what we end up with. And so you can see it maintains most of the general shape, the outlines of the walls in certain places. You could decide that that is too smooth, so you could increase up to maybe 4,000, maybe 3,500, and go through the process again if you like. And then we'll hit same thing again, extract mesh. And so you can see there's a couple more holes now, so maybe the other option was better, but you can see there's a bit more of the intact, more of the geometry is intact to a certain extent. You can see more stones and the lines of the buildings, and you can fix the holes in Blender, so that's not necessarily a problem there, but it all depends on your preference. I'm going to go with something like that. So this way we've only got 1, maybe 2 holes to fill, and that's fine. And then hit save, and save this as decimated, because we've decimated it. And so that is it, and then you are ready to move on to Blender. Okay, now it is time to actually do the normal mapping in Blender. So when you first start, you'll get a window a bit like this. So you'll want to start with a general file. And so you see that there is a cube here that you start with automatically. Go ahead and delete that by right-clicking in the scene collection, that layer, a bit like Cloud Compare again, where we have layers of things. Right, so now we want to get our section in here. And so what we'll do is we'll go to File, Import, OBJ, because that is the file type we saved it as. And so now we will go to the correct file. This. And so we'll start with our cleaned high resolution OBJ. As you can see here, there's a bit of navigation here, so you can leave it as it is here. You'll just have to reorient your brain, now thinking from Cloud Compare when Z was up, now Y will be up, but that's fine. Okay, so that did take some time, but don't panic if it takes a while. Also note that when it finally came in, that this was what I saw. So you will need to zoom out with your mouse wheel or this magnifying glass here to find your scan data. And so next, make sure you import your decimated version as well. And so obviously that was much quicker. You can see it was imported here. So one thing that we will need to do that you don't usually have to do in many of these tutorials is we need to make sure that these stay in the same place. So one thing we need to do that we don't usually need to do if it's just 3D modeled assets, but because this is reality captured data, there's an extra step you need to do for each of these meshes. So you go to Object, as I have here, Apply, and then select All Transforms. And so essentially this will fix both of these meshes in place. And so this is not something you usually have to worry about in 3D modeling, and so often is not mentioned in tutorials. So in this case, reality capture data, and we're putting it in here. So to orient ourselves again, so that things look a bit more familiar, you can click -Y And so to pan, you hold Shift and use your middle mouse button to click down. And so this should look a bit more familiar now. We've got our wall up here, these footings of buildings here. So we did note before that there were some holes in our mesh, or at least in the decimated one. So we'll start here. If you click on your mesh with the middle mouse button, you'll be able to see that these holes are now outlined with orange, saying where the mesh starts and stops, basically. So the next thing we'll need to do is, you can see we're actually in object mode here. So now we want to shift into edit mode, which will allow us to edit the mesh. And so you see these blue lines here, so these are called sharps, and we don't necessarily want these. So because these are edges that are being highlighted with sharps, what we want to do is we want to switch to edge select, hit A to select all, right click with your mouse, and find clear sharp, because we don't really need those. You may get lucky in that the cleanup function might actually find the holes here and fill them automatically. Nope. So because that didn't work, what we'll want to do is hold down the Alt key and left click. Unfortunately, that doesn't seem to have worked in this case either. So another way to get around this is to hold down the Control key after you've clicked somewhere. Click to the opposite edge of the hole. And so that should allow me to fill the hole. Good, and so just do that for each hole you come across. Obviously there's one here. We'll try the Alt left click here, which luckily has filled that in and has allowed me to fill in that hole. And looking to see if there are any more holes. If we go back into object mode, we can click and see if we see any more holes that are evident. I think I see one. Maybe not. Okay, so that's all of our holes there. We'll just double check this one and make sure there aren't any visible holes here. Don't see any, just to be expected. So let's go back to our decimated one. We'll turn off the high resolution one for now. While in object mode, you'll want to shade smooth your mesh. And you may even want to add a modifier to add the subdivision surface here and change levels to 2. And that just makes things look a bit nicer. So now we want to essentially create the image file that we will be mapping our normals onto. And so if you move your mouse over to the top left corner here, you'll get some crosshairs and you'll be able to split your screen by left clicking and dragging to the right. To change this top left here to the shader editor. So you can just hide that away over here. Or you can click N. If you've clicked in here and then hit the N button, that'll make that appear and disappear. Now this is what we want to call a node interface, and so nodes are essentially a form of programming, and so this is more of a visual appearance for that, and with little reusable blocks basically, but they're called nodes. Shift button and the A key, and we'll hit search and we'll look for image texture. So that's the first one we want to add here. We can move that around over here. And we'll do this again to look for the normal map node, which we'll also be using here. And so you'll want to connect normal to normal on the principled BSDF. And we'll want to connect color to color here, as you might have guessed. We might need a bit more space here. And it's just left clicking and dragging from the little node on the side to the other node here. Times 4. Okay. And then once you've created that texture, change color space to non-color. Very important for a normal map. Now that we've created the essentially the receptacle for our normal map, we need to prepare our mesh for normal mapping even further. So what we're going to do next is called UV unwrapping, which you may have heard of. So UV unwrapping is basically like unwrapping a gift, except you're trying to keep all the pieces together. And so essentially you're unwrapping your 3D model into a two-dimensional image. And so you need to make slits in the right places so that it unwraps flat. So let's change our shader editor to UV editor. It'll be a bit more obvious once we start going. And so we've set the image that we created in the nodes as our receptacle for the UV editor. It'll be quite large probably, but you can zoom out with your magnifying glass or your mouse wheel. So because the decimated mesh is going to be receiving the detail, it makes sense to have the map created from the decimated mesh. And so what you'll want to do is you'll want to switch to edit mode, change to faces mode, ensure everything is selected by pressing the A button, and then under UV you'll want to do Smart UV Project, and that should work fine. And so now you can see that this mesh has been broken up into islands essentially and projected onto this image. Now this isn't necessarily the neatest way to do this, so you can see that this isn't all connected really. It's basically little pieces have been sliced off where they couldn't get it to work quite right. So if you wanted to texture this later based on this UV unwrap, that'd be quite difficult. But because it's normal maps and we are just using the software to get the normal map out, that's not such a bad thing here. Okay, so now we're going to go back into object mode over here. Don't be too worried about that. We'll just shift that over here. So now we're going to make our high resolution map visible again. I'm going to switch to one of these so that we can actually have a look at what the main difference is between these two. So you can see that there's a bit of a height difference between the high resolution mesh and the decimated mesh. And so what you want to do is you want to use the measure tool. And so left click that, left click somewhere where it looks like a decent point, and it looks like that there's a height difference of 0.23 meters between the decimated and the high resolution mesh, at least roughly. It's probably different in other places, but that's not what we will worry about here. So we'll want to keep track of what that number was for the extrusion factor later. So now we are going to want more windows. We'll bring our shader editor back in one of these. Now what you want to do here is you want to make sure that all of the nodes are unhighlighted at this starting point here. Now the order of doing this is very important. So we've clicked on the decimated mesh here, we want to click on the image node here, nothing else. So with that highlighted, we will click on the high resolution model and then control left click on the decimated model. And so from here we will move to the render properties tab. You'll want to make sure your render engine is cycles. If you want to try GPU compute, feel free if you have a dedicated graphics card for that sort of thing. So you can see in here we have a lot of options, and a lot of people have their own preferences based on their own machines. For us, we're going to set render to 8. Under light paths, maximum bounces, we're going to set that to 2, while everything else is going to be set to 4. Except for volume. Under caustics, we're going to deselect these. Under performance, we're going to want our tiles to match our image. Then we can go to bake, and we just want the normal map. Make sure selected to active is checked here. That was the whole, that's why we clicked on everything in the order we did. And you'll want to open this up and switch. It was about 1/4 of a meter. That was the difference between our decimated and high resolution mesh there. Once you are happy with all of those, we can click the bake button. And you can see it'll start processing here. So you may have had enough time to make a cup of tea during that processing. You may not have, but what we are hoping to see is this lovely purple, variations on purple image over here. And so this is our normal map. And so it actually seems to have turned out quite well. You can see that there's all sorts of detail baked into it, even if it's in kind of a weird orientation. So once we are happy with this, you'll want to save your normal map in a reasonable location. And make sure you save your image. You'll honestly want to keep it where you have your decimated your decimated mesh, because if you end up moving the normal map at any point, it'll sort of lose its association with the mesh, and it just becomes a bit more difficult than you really need. And so save it as an image. I just want to save it here, please. Thank you. And so that is saved. So the way you test whether it really worked, well, it really worked, but what you want to do is click the shading option on our decimated model. You can see the high resolution model is turned off, and we still have all of this lovely detail here baked into this low resolution model. And so that is normal mapping. And so what you just have to do now is you have to make sure that you export your decimated mesh, because this has been UV mapped now, so this one is now the one you want to export. Here that this is the only thing that is selected in your scene collection. File, export. You may want to do FBX depending on what you want to the sort of outputs you want to work with. OBJ also works, but you can do either or both. You might do both here. we'll put normal map here. Just make it clear. We'll limit to selection only, otherwise it will export everything. And we'll want to have your material groups. Great, and so then you export. Let it do its thing. And we'll just do a FBX just to be 100% sure as well. So if you do FBX, you'll want to make sure that you click Apply Transform. And you don't really need to bake an animation because there is no animation. And that is all fine. So export. And you'll probably want to save this just in case you need to re-export something. And that is it. So that's how you normal map your laser scanned datasets. And so again, you would go through and apply this to each subsection of the multi laser scan dataset. But that is up to you if you continue making the entire thing or if you work on your reconstruction from one subsection. Okay, that is it for exercise 3. So the next video will be for exercise 4 and it'll go through kind of the uses of gray boxing. Okay, see you there.